Welcome back to Maths with Mr. Duffield, a very exciting development for my third form, also useful for my LE. To be honest, it's useful for any IGCSE candidate. Pythagoras Theorem. You've been given some questions on how to apply it. Now, you might have even heard of Pythagoras Theorem, this little line of work here, a squared plus b squared equals c squared. What does it even mean? It relates to the side lengths of a right-angled triangle, whereby the two shorter side lengths are labelled side A and side B. And this longest side length, we label this one, we call this one the hypotenuse. That's side length C. So what does this actually mean? Well, what this theorem tells us is we square the side length of one of the shorter sides, and we square the side length of another of the shorter sides, and it gives us the square of the hypotenuse. This is very, very useful because it means that we can use this to work out missing side lengths if we know 2 in a right angled triangle. I'll show you what I mean. If this side length is A, that means A squared is 4.2 squared. If this side length is B, then B squared is 3.5 squared. Adding those two side lengths squared together gives us the square of the hypotenuse. So let me get out my calculator and quickly do that for you, because indeed you can use your calculator for this if it gets a bit complicated like this is. This makes 32.5. Effectively, what that means is the hypotenuse, c squared, the square of the hypotenuse is 32.5. How do I work out what the value of the hypotenuse is therefore? I square root 32.5. That gives me a value of 5.7. The decimals carry on, but you know what, that's probably acceptable for this question. Okay, the reason that I'm doing this video is not for something as straightforward as this. It's for when it gets a bit more complicated. Take a look at what I've got here. I can label again the two shorter side lengths of this right angled triangle, A and B. The hypotenuse is C. All right, what that means in this particular problem is that the side length that I'm looking for is one of the shorter ones, not the hypotenuse, but one of the shorter ones. Let's write this down again. A squared plus B squared equals C squared. Well, A is 12. B squared, I don't know, it's actually the letter X. And C squared, the hypotenuse, is 13. Okay? Let's work this out. 12 squared is 144. X squared, I don't know. 13 squared is 169. You see, with this, because I'm looking for one of the shorter side lengths, it isn't as simple as adding these two together. It doesn't work for this equation. I've got to take away 144 from both sides. Oh yes, I'm left with x squared on its own on the left, and 169 minus 144, 25 on the right. Square root both sides, you got it. X is 5. This is 5 centimeters long. Okay, so there are two different ways of working with the Pythagoras theorem. When I've got two shorter side lengths, it's just a case of adding both of those squares together and then square rooting. But if one of the things I don't know is one of the shorter side lengths, well, I'm going to have to involve some kind of subtraction. As long as my work is well laid out, it's very difficult to get wrong. Good luck, and God bless you, wherever you are.